Hello. For our next situation in the Chapter 9 test review, it says below are the pre and post-test scores for the beginning algebra competency exam. The pre-test was given before the students attended a mandatory workshop to help improve test scores. Was the workshop effective in improving the test scores at the 5% level? Now, what was given were the pre-test scores, which were 27, 14, 15, 21, 24, 20, 10, 30, and 25. And then the post-test scores, which is 26, 20, 21, 22, 25, 18, 8, 30, and 27. Keep in mind it was the same student that took the pre-test, the same student took the post-test, and these are their scores. And we're trying to find out if there was a difference. So it may appear that there's two sets of data, but there's actually not. The same student took the pre-test and the post-test, and we're looking to find the difference. So what we're going to do is we're going to take the post-test minus the pre-test and see what the difference is. So before we set up the HO and the HA, I'm going to show you how to do this in the calculator to get it set up. So I move my calculator over. I pressed Stat, number 1 for edit. In list 2, I put all the pre-test scores, and in list 3, I put all the post-test scores. But remember, we're not looking at the pre-test or the post-test, we're looking at the difference between the two, and we're going to do post minus pre. So pre-test is in list 2, post-test is in list 3, and to find the difference, I'm going to go to list 4. So I'm going to move my cursor to list 4 and make sure your cursor is on L4. It's not the place where you put the data below it, it's literally on L4. And we'd like list 4 to be list 3, the post-test, minus list 2, the pre-test. So while my cursor is on list 4, I'm going to press second 3 for list 3, subtraction, second 2 for list 2, push enter, and now list 4 becomes the differences. So when you take post minus pre, for example, 26 minus 27, we get -1. So we're going to refer back to list 4, which is the difference list. Okay, let's set up the HO and HA. Because we're looking for a difference now, that means that mu equals 0. The average difference of post minus pre-test is 0, no difference. That's the claim, that's the belief. You have to show me with data if there is a difference. And we believe that the workshop worked, so HA is going to be mu greater than 0. The average difference of post minus pre-test is greater than 0. This is doing post minus pre, and if the post is higher, which is what we're assuming, that would be greater than 0. Again, it's still a t-test, so we're going to check our conditions. It's random, as it should be stated in the problem. We're going to assume the data is normal. Now, if we make a histogram of the difference list, it's not exactly normal. Remember, to be normal, it's safe to have 30 or more. We don't have 30 or more total, so we're just going to assume that it's normal. And then for condition 3, your population has to be greater than 10 times the sample size. So our population is all students taking the exam. Let's say a statistics exam, is that greater than 10 times 9, 90? Yes, there are more students taking a statistics exam than 90. Then we're going to do all the work just like we did for a t-test, and remember we're going to refer back to list 4. So our mu is 0, and to find our x bar and our s, we're going to go back to the calculator and we're going to do we're going to find our x bar and our s in the calculator. So remember, list 4 is where the differences are. So I press second mode to return to the home screen. We press stat to the right for calculate. We're going to do number 1 variable statistics on list 4. So we hit second 4 for list 4, push enter, or go down to calculate and push enter. And we notice our x bar, which is the difference, is a positive 1.222222. And our standard deviation is 3.0322. So we're going to pull from that our x bar is 1.22222, and our standard deviation is 3.0322, and n is 9. So again, it's a t-test. We find our SE. We take our sample standard deviation divided by the square root of n. So 3.0322 divided by the square root of 9 gives us 1.0107. To find our test statistic t, it's our x bar minus mu, which is 1.2222 minus 0 divided by our SE of 1.0107, which gives us 1.21. Now, to do it with critical values, our t is 1.21, So notice it's not too far to the right from 0. It's 1.21 to the right. And we get our critical value from the t-table. Remember, we get our degrees of freedom from our sample size minus 1, so n minus 1 is 8, and then we're looking at 95. So one example of a t-table, we go to 5%, our degrees of freedom is 8, 2.306 is what we get from here. So we use 2.306. So again, if we can imagine in our head, 1.21 would be 1.21 to the right because it's positive. 2.303 would be our critical value. The area to the right of 2.306 would be very small, smaller than the area of what we got of 1.21 to the right. This would be our p-value, the area to the right of 1.21, and then our alpha would be to the area to the right of 2.306, so our p-value is not smaller than alpha. But we're going to find our p-value from the calculator. So to find the p-value from the calculator, again, we're doing a t-test on list 4. So we press stat to the right for test. We're doing a t-test. And we're doing it on list data, we choose first. Mu is 0. The list we're going to refer to is list 4. Frequency, we leave it at 1. And remember, we're choosing greater than in this problem. And we can do draw if we want the picture, calculate if we want the number. So I'm going to choose draw. And we get our test statistic of 1.2092, very close to what we got by hand, and our p-value of 0.1305. We're going to compare that p-value to our alpha. Our p-value of 0.131, our p-value of 0.131 is not smaller than our alpha of 0.05, so we do not reject HO. There is not statistically significant evidence to reject HO. We conclude that the average difference of post minus pretest is not greater than 0. Notice the pattern, do not reject, not enough evidence, not greater than 0. So the difference is not greater than 0. We can't say that the workshop works. And when we do our 95% confidence interval, the formula for that is x bar plus or minus SE times T star. So our x bar is 1.2222 plus or minus our SE of 1.0107 we found earlier, and our T star, which we got from the table, 2.306. If we do 1 minus 1.2222 minus 0.10107 times 2.306, we get the negative 1.1085. If we do 1.2222 plus 1.0107 times 2.306, we get 3.5529. We're going to verify in the calculator and explain what it means. So in the calculator, since we did a t-test, we're going to do a t-interval. So we go stat to the right for test. We go down, 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 down to number 8, which is t-interval. It is data, list 4, frequency, we leave at 1. We're going to change the sea level to 95, or make sure that it says 0.95. Push enter on top of calculate. The calculator is negative 1.0109, comma 3.553, very close to what we got. And now remember, we're comparing post-test minus pre-test. So how did the score change? It could have gone down by a point, or it could have gone up by 3.55 points. Now, if both numbers were positive, that means that going to the workshop worked. If both numbers were negative, actually your score went down by going to the workshop. But because it went down and up, we can't say for sure that it works. So we are 95% confident the average difference in post minus pretest is between lower by 1.109 points to higher by 3.553 points. And then all the calculator steps are listed below in the review, so you can practice later. Thank you.